Hello class, this is a video tutorial on calculating horizontal asymptotes by dividing each term in the function by the largest power of x in the function and testing the function's behavior as x approaches infinity. We can calculate the horizontal asymptote of any function f of x. In the previous video when we talked about vertical asymptotes, asymptotes in general can mostly be found where there are algebraic fractions. Okay, so let's get to it here. By dividing by the largest power of x, what we mean about that is we take a look at the function and we take note of which power of x is the largest. In this case, it's x to the power of 1. And then we're going to divide every term by x to the power of 1. So let's take a look at what this might look like. We get f of x equals this first term, x divided by x over x, minus 1 over x over, that's that one, so x divided by x again, and then minus 4 divided by x. Okay. Let's simplify this expression. X divided by x is 1 minus 1 over x. X divided by x is 1 minus 4 over x. And now at this point, we're going to let x approach infinity. Alright, and let's take a look at the behavior of what will happen. Well, 1 and 1 stay the same. Now, if 1 divides by a very large number, isn't that essentially going to be minusing 0? It gets so small that it's practically 0. In the same case for this, that's going to be minus 4 divided by a very large number, that is also 0. So this leaves us with only 1 over 1, and our horizontal asymptote is going to be at y is equal to 1. And that's how we do it. Let's do a few more examples here, right? And let's evaluate some more horizontal asymptotes. Here we go. Let's take note of which is the largest power of x. In this case, it is x squared. So let's divide everything by x squared. So f of x is equal to x, this first term, divided by x squared, minus 1 over x squared over x squared divided by x squared, minus 4 divided by x squared. Let's evaluate these values. In this first term, one of the x's can cancel, so we get 1 on x minus 1 on x squared. That's the same. X squared on x squared is 1. Okay, and this is going to be still negative. Oops. Negative 4 on x squared. Right, once everything is as simplified as it can be, we let x approach infinity. Let's take a look at the behavior of all the numbers. 1, let's do this first term here. 1 divided by a very large number, that becomes 0. 1 divided by an even larger number, that's also 0. That stays as 1 minus 4 divided by a very large number is also 0. This ultimately will result in us 0 over 1, and that just evaluates to 0. So our horizontal asymptote is at y is equal to 0. Once again, we're going to take a look at what this might look like when we graph these functions. Let's move on to the last example here. In this last example, the largest power of x here is x squared. So we're going to divide every term here by x squared. So our function is going to look like the following. F of x is equal to negative 4x squared divided by x squared minus 5x divided by x squared plus 3 over x squared. That's the numerator. Let's do the denominator now. It's going to be negative 3x squared divided by x squared minus 5x divided by x squared plus 4 divided by x squared. Evaluating some points here. Those two x squareds cancel, which leaves us with negative 4. One of these x's, subtract with that, so it's going to be negative 5 on x. And this point here stays the same, plus 3 on x squared. All over. These x squareds cancel in the denominator, leaving us with just negative 3. One of these x's will cancel, leaving us with negative 5 on x. And this last term stays as it is. It's going to be plus 4 on x squared. And once again, we're going to let x approach infinity. What happens here now? Negative 4 stays the same. This becomes 0, as well as this. All over. Negative 3 stays the same. This becomes, minus 0, plus 0. And in the end, we're left with negative 4 divided by negative 3. So positive 4 on 3. And that is where our vertical asymptote is found. So hopefully that gave you an insight into calculating the horizontal asymptote, of functions involving algebraic fractions. Hope to see you in the next video. Best of luck.